example 1 has 2x minus 7y minus 5 equals 0. 4x plus 3y plus 7 equals 0. So we want to get rid of one of the variables. It looks like the 2x and the 4x are nicely just double of each other. So I'm going to eliminate the x variable. So I'm going to take equation 1. I'm going to multiply that by 2. And we end up with 4x minus 14y minus 10 equals 0. So we're going to subtract equation 1 from equation 2. And so we end up the 4x's cancel out. 3y minus negative 14 is going to give me 17y. Here I'm going to end up with plus 17 equals 0. I can see that y is equal to negative 1. So solving for x, I can plug it back into one of the equations. So I'm going to plug it back into equation 1. And I end up with 2x minus 7y. So it's going to be 7 times negative 1. Minus 5 equals 0. Solve for x. This becomes plus 7 minus 5 equals 0. 2x plus 2 equals 0. So again, x is going to be equal to negative 1 as well. Okay, so x is equal to negative 1. Y is equal to negative 1. There is only one solution for here. So these, if we take a look at the coefficients again, 2x, negative 7y, 4x, positive 3y, they are not in proportion to each other. So they do not have the same slope, so they must intersect only once. Here I can maybe eliminate, well, it looks like this one might be a little bit harder to eliminate. The proportions are not the same. So I'm going to multiply both of these equations and get a lowest common multiple. And maybe we'll get rid of the x. So I'm going to multiply equation 1 by 3 to get 24x minus 18y equals 150. And equation 2 will multiply by 8 to get the lowest common multiple of 24x. This becomes 80y plus 8 times 18 is, that's going to be 80 plus 64 is 144 equals 150. Okay, does that look right? That looks right to me. So we're going to subtract these. So subtracting these, we end up with negative 98. Let's equal 0. Negative 98y minus 144 is equal to 150. So negative 98y is equal to, add both sides, I end up with 294. So it looks like if I divide by negative 98, that's going to end up with negative 3. So y equals negative 3. And then substituting back, I'm going to solve for x. So I'll substitute in equation 2. And again, notice I'm keeping track of these equations. I want to number them just so I know which equations I'm dealing with, because we don't ever want to substitute things into themselves, because that will give us inconsistent results. So I plug in my negative 3 into my y value. 3x minus 30 plus 18 equals 0. So 3x equals positive 12. X equals positive 4. Okay, and if I plug it in, 4 times 8 is 32. Y times negative 3 is going to be, so 6 times negative 3 is negative 18. So minus negative 18 gives me positive 50. Okay, substituting into here, we get 3 times 4 is 12. 10 times negative 3 is negative 30. So 10 12 plus negative 30 is negative 18, plus 18 gives us our 0. Okay, so these are the x and y that would solve this equation. And again, there's only one solution here. Okay, so yearbook committee must decide on which two companies to print their yearbooks. So company A charges $2,200 initial fee plus $8.25 a book. So company A has this relationship. So the cost related to the number of books is going to be $2,200 plus $8.25 per book. Okay, company B, it has a bigger initial cost. Oops. Okay, so I just need to rezoom here. It has a bigger initial cost, so the cost is equal to $3,600 plus they charge less per book, so $5.10 times the number of books. Okay, so I'm going to write this into y equals mx plus b equation. There's my slope, which is my rate in my equation. Equation 2, or b, is going to be y equals 5.10x plus 3,600. So we're going to solve this. I can just substitute one into the other. So I'm going to make the y's equal to each other. So $8.25 times the number of books plus the original $2,200. And we're going to find out where these are equal. So $5.10 times the books plus $3,600. So we want to figure out how many books do we need to make Company B the better deal. So Company B charges less per book. So if we have lots of books, we'll overcome that original initial cost and save for each book. We'll have savings for each book compared to the $8.25 a book. So we want to find out where they're equal, and the number of books above that is going to be where Company B will be the better deal. So I'm going to solve this equation. Subtract 2,200 from both sides, so I end up with 1,400 on this side. I'm going to subtract $5.10 from both sides, so I end up with $3.15 per book. Okay, so I'm going to divide these. Okay, so divide 1,400 by $3.15. Okay, so when I do that, I'm going to end up with x is equal to 444.4 repeating. So that means that at that point that the costs will be equal. You can't buy part of a book. So if we buy 445 books and greater will be better to use Company B.